Well, welcome back. This is Unit 2.1, and we're going to be talking about the properties of matter. And in your textbook, this is page 36 through 39. So please make sure that you read that. All right, so starting off, classifying properties. Chemistry is a science concerned with properties, the composition of matter, the behavior of matter. And in chemistry, we take these properties, which are the qualities of a thing, especially those that are common to a group, and we separate them out into groups. So say, for example, this one right here, this first one, these have been classified according to the color red. So all of these things have that in common. In this middle section here, these have been classified according to salty snacks. So all of these things here are salty snacks. And over here on the right, these have been classified according to their heaviness. So we have here that these weights are heavy. These concrete blocks they're trying to move, the bulldozer are heavy. The plane is heavy, etc. So classifying according to properties. The first property that we're going to talk about is this extensive and intensive properties. Now, these first three videos that we have in Unit 2 are chock full of vocabulary and definitions, so you're going to be needing to write all of these down. So make sure that you're pausing this video and writing this down to get it into your notes. All right, so the first two definitions are extensive properties and intensive properties. So go ahead and pause and write those down. All right, extensive properties are properties that are dependent on the amount of material that's present, while intensive properties are properties that are not dependent on the amount of material that is present. And the way I like to think about this is have a bowl of blue M&Ms. So let's say, for example, we take one of these M&Ms out of this bowl. Okay, so for extensive properties, it does matter how much we have. So think about the mass. So let's just say the mass of this one M&M is 1 gram. So we have one M&M, that's 1 gram. But if we were to take another M&M out and put it here, then that would be 2 grams because we have more M&Ms. And again, if we took another one out, that's 3 grams because we have 3 M&Ms. So mass is a property that does depend on how much you have. Okay, some more properties are volume. The more M&Ms we have, the more volume we have. Length. So if we were to set these end on end like this and measure the length, this length may be 3 centimeters, but if we have 3 of them, now that's going to be 9 centimeters. And weight. Weight is also dependent on how much we have. These 3 M&Ms are going to have less weight than this whole bowl of M&Ms here. Now, intensive properties that do not depend on how many you have. So let's say, for example, let's look at the first color. So if I just take one of these blue M&Ms, it's blue, right? So if I take another one out and add to this pile here, do these M&Ms change color? No, they're still blue. And I could take a third one out. They're still blue. I could have a truckload of these M&Ms and they're still going to be the same color, blue. So this does not depend on the amount of material that you have. That's intensive properties. Okay, so more intensive properties are melting point, density, taste, and freezing point. And density is one that we're going to keep talking about more and more. Density, let's think about a stick. So we have a tree. Let's take and let's cut off a limb of that tree and let's throw it in the lake. Well, that limb is going to float, depending on what kind of wood it is, but most of the woods around here, the wood's going to float on top of the lake. Well, if we cut down the whole tree and we throw the tree in the lake, is that whole entire tree going to sink or float? Well, the answer to that, it's still going to float. Now we could take that tree limb and we could carve it down to a popsicle stick, and it's still going to float. The density of that wood is the same. Now you may be sitting here thinking, a whole tree, if we throw a whole tree in the lake, it's going to float. Yeah, think about, you see pictures all the time of logging where they've cut down these trees and then they float them down the river to a certain point, and then that they extract them or take them out of the river and then load them on a truck. Those trees are floating. And sometimes, they have lumberjack games where two lumberjacks stand on a tree and they're facing different directions and they roll the tree by walking on it and try to make the other person fall. Those are whole entire trees or sections of whole entire trees that are floating in the water. So yes, density remains the same no matter how much of that particular thing that you have. So that's an intensive property. All right, so physical versus chemical properties. So again, this is going to be some writing, so go ahead and pause and write these definitions down and these examples. Physical properties describe a physical change such as melting, boiling, shape. The substance remains the same substance, it just changes in its appearance. Another example would be taking a piece of paper, crumbling up that piece of paper to throw it away. Well, before you crumbled it up, you were writing on it, it's paper, right? So you crumble it up, it's still paper, it's just in a different shape. So paper has physical properties. Those are physical properties of that paper. However, chemical properties describe the relationship or interactions between matter. The substances interacting take on different properties than their original form. So if we were to take that same piece of paper and set it on fire, it's not paper anymore, it's ash. It's gone through some kind of chemical change that's changed it from paper to ashes, and we can't write on it anymore. We can't use it. Okay, so more physical changes and physical properties are going to be like baking soda and vinegar, like our Alka-Seltzer rocket. When we put the Alka-Seltzer in water, it chemically reacted with that water and it created carbon dioxide bubbles. It's no longer the same product. It's no longer Alka-Seltzer. It's chemically changed. So the baking soda and vinegar, when you mix it together, it chemically changes. We cannot get the baking soda back. We cannot get the vinegar back because they chemically reacted. Okay, and some examples of chemical properties are reactivity. That's what we've just been talking about. The heat of formation, which is the energy release when new substances are formed. And the heat of combustion is the energy release when something burns. So we talked about the paper burning. We talked a little bit about energy when we're talking about temperature and the units for temperature, but I just want to have you write this down and reiterate this. Kinetic energy is any form of energy that can't be stored. We call that the energy of movement. Thermal energy is the total kinetic energy of an object's particles. And this, by the way, is an extensive property. And then we talked about temperature being the average kinetic energy that a substance has. So make sure you have those written down. States of matter. I know we talk about states of matter in elementary school, and I'm sure that you had states of matter that you had when you were in junior high science, and we're going to talk about states of matter. This is really important in chemistry as well. So go ahead and pause the video and draw this chart and write this in there. All right, so the three main states of matter that we're going to talk about in chemistry are solids, liquids, and gases. And for solids, they have a fixed shape and a fixed volume. And these particles do move around and they do bump into each other, but they're so tightly packed and so close to each other that the space that is there is not big enough for other particles to pass through it. So it's kind of trapped in this one shape, in this fixed shape. For liquids, they adopt the shape of their container, but it still is a fixed volume. The volume doesn't change. The particles are moving faster than in a solid, and they are hitting each other a little harder. So there is a little bit more distance between the particles, enough distance, just enough distance that the particles can slip past each other and move around. Like this particle here can move through this gap here. And so they move against and around each other. And then in a gas, gases adopt the shape of their container and the volume of their container. Now, these particles have enough energy, so they hit each other with enough force that they escape the attraction that they have to each other. So these have a lot of space between them, and these particles are moving. You can see that these lines here indicate they're moving faster, and they move and strike the inside of the container, and then they bounce off. So these take the shape and the volume of their container. Okay, solids, liquids, and gases. And finally, the last two things we're going to talk about. Make sure that you pause and write these down. All right, so the kinetic molecular theory describes matter and the way it moves. There's 4 statements here that you need to know. All matter is made up of tiny particles. There's empty space between these particles. These particles are always moving, and these particles move because of the energy that they have in them. And phase changes, we need to define these phase changes. We're going to talk about these in chemistry. Freezing is from a liquid to a solid. So from a liquid state to a solid state. And it's also called solidification because we don't talk about metals freezing, we talk about them solidifying. So solidification and freezing are the same thing. Melting is when it goes from a solid to a liquid. Evaporation goes from liquid to gas without any added energy. So water on the sidewalk can evaporate because of the sun's energy, but we don't purposely add energy to that. Now, vaporization is when we add energy, purposely add energy. So when you put a pot of water on a stove and we turn on the burner, then that is vaporization because we're purposely adding energy to that. Okay, so that's called vaporization, but it is still liquid to gas. Condensation is the moving of a gas to a liquid. Sublimation, you may or may not have heard about this word. Sublimation is from a solid straight to a gas, so it skips the liquid phase. And this happens in winter when it's really, really, really cold outside. And like say we get snow or ice. If you had like clothes hanging on a clothesline or something draped over a chair to dry that was wet, and then it freezes, that solid water can go straight from a solid to a gas without passing through the liquid phase. Okay, and that's called sublimation. And deposition goes from a gas to a solid. Oh, another example of sublimation is dry ice. Is it called dry ice? Yeah, dry ice, which is really frozen carbon dioxide. You can buy this at Kroger. And a lot of people use it at Halloween. They drop it down into a liquid and it looks like it's boiling. Well, but what is happening is that carbon dioxide is going straight from the solid state to a gassy state. It's skipping the liquid phase. So dry ice is also sublimating. And then again, deposition is going straight from a gas to a solid. It skips the liquid phase, going from a gas to a solid. All right, that's it. Please make sure you slap that like button right across that face. Give me a thumbs up and give me a subscribe.